In this tutorial, I'm going to show you how to simplify some radicals, and so that we can use this concept later on when we learn about other things. So, first of all, we need to know how to rewrite radicals in terms of exponents. So the most basic form of any kind of radical that you're going to see is a square root of one term. And this is understood because it's a square root. There is understood to be a 2 out here where the radical is. And the reason why we don't write it out there is because it's understood. It's kind of like a coefficient of 1. So I can always rewrite square roots as something to the 1/2 power, like this. When we have a radical that is not a square, that's when we start seeing all of the numbers so that we know exactly what kind of root that we're taking. So in this instance, we're taking the cube root of x, which I can write like such. So x to the 1/4 power. So what about something else? So take a look at number 3 and take a guess as to what you think the answer might be. And if you said x to the 1/5 power, you would be correct. So what about if we take, say, the square root of x to the 3rd power? Okay, so I want you to understand that, go back up to number 1, that this square root represents the denominator in this fraction. Look at number 2. This root determines the denominator of this fraction. And in number 3, the same exact thing happens. So no matter what, whatever root that we're taking is going to be the denominator of the exponent. So in number 4, since there's nothing written outside, we understood it to be 2. So I know that in the end here, this is going to be something over 2. So we can take a pretty good guess as to what the numerator of that exponent is going to be, because x is being raised to the 3rd power inside, so 3 is going to be the numerator. So that's how I can do that. So the square root of x to the 3rd power is the same thing as me saying x to the 3/2 power. Let's take a look at another one. So in this, try to think of what you would get if you were to do this on your own. So try to take a guess first. I'm going to get my x written and then my fraction set up. So once again, the root that I'm taking, in this case it's 3, is going to be the denominator, and whatever power x is being risen to inside the radical is the numerator. So x to the 2/3 power. Notice the subtle differences between numbers 4 and number 5 here. Okay, so then let's do something like this. If I have, that's a 5. That doesn't look very much like a 5, sorry. And then x to the 10th. Well, so that would be the same thing as x to the 10, over 5, which happens to reduce to x squared. And that's pretty interesting, because you wouldn't think that that would be x squared, but that's how it reduces, so it's got to be true. So let's take a look at some problems where we have to simplify numbers within the radical. So number 7, I made this to be very, very simple because I want to show you how we can break this down. In order to break up radicals into the most simplified version, you want to almost do a factor tree. So I can rewrite 25, and I'm trying to think of prime numbers here if at all possible. And 25 happens to be 5 times 5, which I can separate then into the square root of 5 times the square root of 5. So these are just some different ways of writing this so that we can look at some other examples. But overall, we know that the square root of 25 is equal to 5. So what if I want to know the square root of 45? So I don't think that that's the most simplified version we can possibly get, because the goal here is that in the end, whatever is left under the radical is a prime number. And sometimes we're not going to always be able to get it down to nothing but primes, but there should definitely not be any perfect squares anywhere inside of our radicals. So I'm going to break 45 down into all of its factors, so I can get right down to the nitty-gritty of this. So 45, let's see, is the same thing as 5 times 9, and 5 is prime, so I'm going to leave it here, and then 9 is 3 and 3, and both of these 3's are prime as well, so I'm done with my factorization. So I'm going to rewrite the square root of 45 as 5 times 3 times 3. And if there are any pairs of numbers here, like the 3 and the 3, I am going to try to keep those together when I separate this off. So in other words, I'm going to leave the 5 all alone because it doesn't have a pair. And then out to the side, I'm going to rewrite the next one as 3 times 3. And the square root of 5, once again, does not change into anything, but the square root of 3 times 3 is the same thing as the square root of 9, which I know to be 3. So this is the square root of 5 times 3. But we don't ever write our answers like this. If there are any whole numbers, we write them in front of the radical. So this would be the simplified version of the square root of 45. Let's try another one. Okay, so how about let's do the square root of 80. So once again, I'm going to start my factor tree, and I'm going to start breaking this down as much as I can. I know that 2 goes into 80, and 2 fits in 40 times. This is prime, so I'm not going to break that one down anymore. 40 is going to be 5 times 8, and 5 is prime. And then 8 is going to be 4 times 2, which 2 is prime, and then 4 is 2 times 2, and both of those are prime. So I'm going to go ahead and rewrite this as the square root as the product of all of these. I'm going to write 5 first so I can keep all of my 2's together, and there are 4 of them. So 1, 2, 3, 4. Alright, so I'm going to rewrite this, and I'm going to keep them in pairs if I can. So this right here is one pair, square root of 2 times 2, and then this is another pair, so square root of 2 times 2 again. So this is the square root of 5 times the square root of 4 times the square root of 4, and I know the square root of 4 to be 2, so times 2 times 2. So this here becomes 4, because 2 times 2 is 4, so my final answer is 4 square roots of 4. And that is the simplified version. And that concludes this tutorial.